Next, let's go open a new NC documents. Make sure you choose MM, and then I'm going to save this as phone NC1. And now I'm going to load the font into cimatrone. Okay, I'm going to use a default setting, then OK. And also I'm going to load my Y's here into cimatrone. Right. So again, I put roughly at these locations. Next, I will go to the cat mode. Click this icon, and then the first thing that I might need to do is to create a set. Yeah. So I'll create a set for part. Okay. A set for the Y's, or I put as a jig. Okay, so let's off the jig, the Y's. And look at here, the UCS is here. So normally when we machine this kind of part, the machine coordinate system, the machine 0 point or the setup UCS, it will be at the top center of this insert. So how to create that UCS? You can always go to tandem and UCS, select center of geometry. There you are. You have a few default points, and choose the top centers, this point, and you have an option to create a box also if you want. So I just create this UCS without a box and click OK. Here's the UCS. So I'm going to change the name of the UCS to maybe G54, our machine setup. Right? And as you can see, the active UCS is the model UCS. If you want to change it, you can change. You just select this UCS and right click and select activate UCS, and it becomes red color. That means this is now the default UCS, the active one. If you want to off the display some of the UCS, you can use this UCS filter here. You can select all, and you list everything and just close it. Yeah, so I just display only G54. Okay, that's regarding the UCS. Next, I will reposition this Y's here. I'm going to move linear. So I'm going to move from maybe this point to this middle point here to clamp this insert. Okay. Again, so let's move this right to maybe this point to this point to close it. Right. Of course, you can program this part without the Y's if you want. Yeah, it's up to you. And now I'm ready to start my first machining, first buffing process. So let's go to the NC by selecting this, switch to CAM mode. And now, the first thing that you need to do is actually create a toolpath. That means a folder that contains all your cutting process. And you see the start point XY. This is where the tool will come before start machining. So I'm going to put X0, Y0, and the Z is 50. That is a clearance. That means the tool will always jump to this level after machine all the parts. Yeah. So this clearance it must be the highest point. It must higher than your clamp or than your jigs. Yeah. To avoid any unwanted collisions. I think 50 is okay for this part. And comment, just comment. You can key in anything for training, for example. Yeah. And the UCS, of course, here is the default G54. You must specify which UCS you want to use for the machines, and of course, the number of axes. If you have only 3 axes, you can only use 2.5 or 3 axes. Okay, and for 4 and 5, you need to have the 4-5x module. Let's choose 3 axes for now. And the name of TP, you can change any name you want. The default name is TP_underscore G54. Okay, that's okay for the two-part settings. And there you are, here. And after you create a folder, so the next thing is to create a part to tell the cimatrone what you want to cut. And you just click the part, and by default, cimatrone will select everything that you see on the screen. And this is the thing that we don't want it. So we just right click and reset. And of course, you can select the surface one by one, okay, like that, or you make a window, okay, like that. Okay, and if you make a window, sometimes you might mistaken select the face of the Y's as well. Okay, so I'm going to right click again, reset everything. That's why just now we created 2 sets, 1 set for the part, 1 set for the Y's. So let's select the surface by criteria. And with this by criteria settings, I actually can select some geometry by the set. I'm going to choose a part and okay, all the surface in the part set is selected. And click OK. This will tell cimatrone what you want to cut. Next thing is to tell cimatrone what is your initial stock looks like. To do that, you click on the stock. Again, by default, cimatrone will select everything that you see on the screen. Okay, so I'm going to right click and reset all. And again, I will use of course, this setting here, I will use a bounding box. So I will use a select surface by criteria and choose a set part and click OK. And cimatrone will automatically calculate the bounding box for this part here, right? You can see, let's go to this view, front view. You can see on the top there's no extra material, right? So I'm going to add in 5 mm material on top. So I'm going to change back to the box, and here I actually key in the dimensions 5, and you can see now I have 5 mm extra material on top for the machinings. If this is okay, you just click OK. This is the stock. Next, we're going to create our first machining process, the roughing process. Okay. Before that, we have to create a cutter for it. Click on cutter here, and here you can create a new cutter here as much as you want, or you can delete a selected cutter. Okay, so I'm going to create a new cutter here. Put my name rough mill cutter with 32 diameters, a radius for example 6. Technology, of course, is milling. We're going to use a milling cutter. Magazine number, this is the 2 number, T1. Okay, now it's T1. Diameter, I'm going to put 32. And of course, I'm choose you have a flat, ball, or bull. So I'm going to choose a bull. No. Diameter 32, and corner radius is 6. Cutting length maybe 12, and clear, let's put it maybe 60. Okay, so this is cutter that we're going to use for now. Okay, Let's ignore the holder, right? We just use a cutter without holder. And click OK to create the cutters. Okay. After you create the cutters, next is to create the first roughing process. And just click on the procedure. Here you are. And if you click on the procedure, you might have two different type of display. You have one is a wizard display. Okay, let's close it. Another one, I will click on this icon here, switch to advanced display. This is the advanced display. Okay, so it's different. So normally I would like the wizard mode better. Okay. The column over here actually you can customize. Yeah. For example, if you don't want to look at the pen, the thickness of the pen, you can right click this column here of the pen or on the pen. On the pen. Okay. So you can do that. And now let's create our first cutting process. Click on procedure. Make sure your mouse is highlighted here. The stop is highlighted, is in orange color. And then you click on procedure, right? So if you do that, it will create the new procedure below the stock. And now here, this wizard window, you have a few parameters here. You have the geometry tab pages and the cutters and the motion parameters and the machine parameters. And you need to do something. The first thing is the geometry. The geometry you have to select, for example, the path surface. Select which one that you want to cut, right? So just click on the 0 here of the path surface, and of course you can pick one by one the surface, one by one, right? And I think if you still remember, initially we have created one set for the path surface, right? So I'm going to select the surface by criteria by using the sets. So it will be much faster by doing this. Click OK, so all the face inside the path set is automatically selected. So now you can see here, pick by criteria for this surface. Okay, if you pick manually, it will show you also the number of surface that you pick manually. How about the boundary? Yeah, if this is a core or punch, you actually no need to select any boundary, yeah, unless it is a cavity. And next is to select the cutter. Go to the cutter, and of course we're going to select this cutter that we created just now. Okay, and next is go to motion parameter. Inside motion parameter we have a lot of different settings. Yeah, let's ignore all the settings except one or two. Let's go to the tool trajectory here, and let's look at this. The fixed vertical side step, that means each level how deep you want to machine. The value is 0.4 times TLDI. TLDI, that means that is a 2 diameter. So the value of the 2 diameter is 32, right? So maybe what I want is let's keep 0.5 times CRRD. So CRD also is another variable for the tool that stands for the cutter radius, corner radius. So I'm going to use the 0.5. Maybe I'll start with 1 times corner radius. That is the 6 mm of the vertical step, and see how is it. Side step, I'm going to set to default 40%. Okay, the side step. And of course, true spiral machining is preferred, right? So after I key in this vertical step and the side step, in cimatrone actually we can preview the result before we calculate the toolpath. So what you need to do is just click on the preview icon here, preview, and let's drag this aside, and there you are, the preview remaining stock. Maybe I'm going to change the color to this color and click the spectacle here, and you can see the actual remaining stock without any calculations at all for the two parts. This is very unique in cimatrone, that you cannot get it from any other software. Okay. It seems that the vertical step is too big for this part, so I'm going to change the vertical step now here, maybe to 0.5 times CRD. Of course, you can key in the value straight away if you want. Okay. The advantage of I'm using variable is if I change the tool diameter or change the top radius, this setting will automatically change also. This is the advantage. And let's preview again to see the final result. This is better with the 3 mm vertical step. Okay, that's good. Let's cancel the preview. And next, what we need to do is to set the RPM of the feed rate for this. And let's go to machine parameters. Okay, this is machine parameters. Here, you have a calculator. If you want to use, you can use it. For example, I'm going to change the cutting speed of my material. Let's assume it's 200. Flip of 2 for the insert maybe 0.4, right? And straight away the feed rate and the RPM is already calculated. The number of teeth is defined when you create the tool. You just save and close it, and you override the value over here. Maybe here I just round it up to 2000, and this may be rounded up to 1600. The feed rate, and this is the entry feed. Okay, you can choose to slow down when the tool entry to the part or plunge into the part. Okay, you can control. 30 means that 30% of the feed rate of the 1600. Maybe I'll change to maybe 70%. Okay, it's up to you. 70%. Adaptive feed control. If you on this parameters, what happens is the cimatrone will slow down the tool according to a tool load. If the tool load is very high, it will slow down the tool, slow down the feed rate down to minimum of 30%. You can set it, you can change. If the tool load is not high, very less load, it will speed up the feed rate to up to maximum 150%. Again, you can change the setting according to what you want. Okay, so the result is your G code will have a lot of different feed rate at different lines. For now, we just ignore it. We're not going to use this. Next is to go to the coolant. Okay, go to the coolant, and of course now it's off. The value is off. Let's show. Off is M09. Right, so you have the option to, maybe I'm going to choose flat M08 to use coolant for this machines. There you are. All the four tab pages has been set. So the next step is to what? Is to choose what you want. You have here save and close. That means you just save the setting without calculations, or save and calculate now, or just cancel what we have just done. Of course, click on the save and calculate to calculate our NC. There you are. The purple line and the red line is actually the rapid motion and the max speed. The purple is max speed motions, right? The line with other color is actually the machine cutting line. Okay, cutting path. To look at the simulations, you can just select this process here and click on machining simulations. Select the standard, material removal, check against part if you want, and then use a turbo. No need to use a double check. Turbo and click OK. And cimatrone will load the standard simulator. This is the standard cimatrone simulator. Okay, you can rotate pen up to you, right? You can speed up or slow down. Here's the play buttons. Okay, so you can play, pause, or you can drag this bar to a certain location. Okay, fast forward and go, speed up. A lot of settings that you can do with this simulator, so you can have fun with it. Right? So this is a simulator. So after you finish the simulations, you actually can check, do some checking by comparing to the part. Just go to the analysis and just go here and select the deviations. So from here you can see the color. Okay. For example, if you see the deep blue means that what? Deep blue means that over here you have more than 2 mm material left. Okay. If you don't see any orange or red, that's good. This orange and red is bad part, right? There's no orange and red. This is good. This means that this program is safe to cut. Let's close the simulator and go back to cimatrone. Okay, now we're going to optimize the parameters for this roughing process. Let me change the command first. Rough RGH. Okay, this is the command. Let's look at the parameters again. First thing that go to the motion parameters. First thing that I'm going to look at is the clearance. Okay, clearance over here. So now the default clearance is 50, right? The internal clearance, I have two options. One option is to absolute or optimize. Okay, so if you use absolute, here you can assign the absolute clearance. What do you mean by that? Okay, you can see now the value is 50. That means look at the jumping. Or every jumping actually is jump to the coordinate z coordinate 50, right? So if you want to lower this jump, it is possible. How to do that? Okay, one easy way is to change the internal clearance absolute and change the absolute z here. I will change to 10, right? And I'll calculate. Okay, now as you can see here, I will use the navigator. Just select this process, select navigator, so I can hear. So it start from level 50 and go down and do some machinings, right? So after, if there's any jump at between, it will jump only to the 10 mm that I set the internal clear. After finish, it will jump back to Z50. This is what it means. Let's look at the parameters again. Okay, absolute. So how about the other options? The optimize clear. Change optimize. Okay, And additional safety jack, my suggestion is put in 1 to 2 mm. Okay. If you choose internal clearance optimize, the system will calculate the clear automatically, detecting the highest point. Okay, let's calculate. So if you look at the front view, so now the internal clear you have different value, not constant. Compared to just now, always up to 10. Now somewhere is maybe 10, somewhere below 10. Okay, this is optimized clear. So one thing regarding this optimized clear, if you use internal clearance optimize, I will strongly suggest that you go to the machine parameters and change this air motions. Okay, change air motions. All the max fit motions change to max fit. Okay, all the air motion change to max fit, and the feed rate you can put in 15,000 or 10,000. That is okay. Why we need to do this? Let's look at this diagram here. Now let's look at the first code. Let's consider now I'm going to my current cutter position is here at x0, y0, and it is going to these locations. That's the 300 and y200. If I command this code on the machines, okay, this code on the machine, G1, X300, Y200, and with a feed rate maybe 100 or 1000. So what happens is the cutter, of course, it will go straight to this point. Okay, this is normally what your machine do. And what happens instead of G01 if I change to G00? Okay, commanding the same code. This is what happens when the machine reads Z00. That means both of the motor is turning at the same speed, or both axes is moving at the same speed. That means they will move to 200 by 200 first. 200 by 200, then continue to the X300. So on the machines, the actual path is not straight on some machines. Okay, and so this is very dangerous. If you have something behind over here, and if you use the optimized clearance, this motion it might gouge the part. Okay, and this type of gouging you cannot check with the simulator. In simulator, we will always assume the G1 and G00, the motion is straight. It is straight. Okay. Due to that, if you use optimized clearance, please change the air motions, the max fit air motion, the G001 to max fit instead of rapid. Rapid is G00, and you must change to max fit, yeah, with a feed rate. And calculate. So this is regarding the clearance. Now let's look at the motion parameters again. Okay, we have done the clearance and the entry. In entry, most of the time we use optimize. Okay, and you can set for the ramping angle. Okay, this is for in case you have a hole to machine it. Okay, if it is a core, if the tool can come in from outside, if the tool will prefer to come in from outside, it will not plunge. But if you have a hole, okay, a cavity, the tool have to plunge. Then here you can set a value, okay, how many degrees the tool should plunge. So maybe I'll put in 10 degrees. After you put in 10 degrees, you have the maximum ram radius that you can put in. The default 48% of the cutter, I think this is enough for the tool. And how about this minimum plunge size? Okay, as you know, for a Buno's insert cutter, the center of the cutter actually cannot be machined. If this cutter cut a very small hole, of course the material will build up and hit the bottom, and this will cause the cutter to break. Okay, so this one you can specify a value. Okay, here I can key in a formula like this: the 2 times meter minus 2 times of the corner radius. This will be equal to the flat bottom flat area of the cutters. Okay, so if I put 20 means that if there's a hole smaller than radius 20, the cutter will not cut the hole. This will prevent the cutter to hit the bottom. Okay. Next, this connects passes wire clear for this distance there. Okay. So this is the default value. Okay. You can set. Okay. If the next point after machining the current point, if the next point that you need to go for the cutter is less than 4 times of the cutter diameters, okay, it will do a internal connections instead of jump up to clear. If more than 4 times, that means it will go to the next point by jump back to the clear. This is the meaning for this. The default, I think, it should be sufficient for this. That's entry. The boundary, we don't use any boundary here, so you can ignore this. Upper tolerance, of course. Yeah. This is a roughing process or a volume milling process. You need to leave some material for the semi-finishing process, or sorry, the finishing process, or else the finishing process got nothing to cut. So the part surface offset, for example, I need to output maybe normally in workshop it will be around 0.1. Okay, again it depends. So for this training I just put 1 mm. And so surface tolerance. So to surface tolerance you can consider it is the plus minus of the machining. Okay, so if you put in 10 micron, that means after you machine out the part, some area will have plus 10 microns and some area will have minus 10 microns. Okay, this is the meaning. So one thing for sure is your surface offset must more than your surface tolerance. Okay, must be more than your surface tolerance. So in this case, if my surface offset is 1 mm, the first surface tolerance, if I want to increase, I can still increase maybe to 0.1 or to 0.5. It is still okay. But normally, the maximum that you can go, I suggest maybe go for 0.1. Surface tolerance, the plus minus. So if you use 0.1, that means the code will be lesser and the machine run faster, of course. Max contour gap, you can ignore this. The default value is good enough. So I put 1 mm for the finishing. Electrode milling is for electrode machines. Okay. If you machine an electrode, normally you don't play with the offset here. The offset here you can put 0 most of the time. So you can just on it, and here you can key in the 2D orbit gap and or the 3D orbit gap. It depends on you. So for now, this is not electrode. Let's cancel it. Okay. And how about two trajectory? Two trajectory. Just now we have put in the vertical step, a side step, and set it to be a true spiral. Okay. How about others? And first thing we look at is the calculations. Okay, your options. You have high accuracy, optimize, or faster. What it means that most of the time, of course, you use optimize. And if sometimes you need to have very high accuracy on the calculation of stop, then you use high accuracy. Okay, and you use optimize. You can press F1 to read more regarding these settings. Okay, climbing milling. So here you can set whether you want to go for climb or climbing or all conventional or mix. Okay, if you use mix, the jumping it will be minimum, or you can use a mix and the final pass is climbing, or the mix or final pass is a conventional. This is setting. And the cutting strategy. Cutting strategy, most of the time, again, you will use the optimize. I would suggest to you to use optimize. Okay, unless you need a spatial cutting method. Okay, you still can go use a define and change to different cutting style. Okay, so let's stick with optimize. For the vertical step task, okay, currently what we use is a fixed vertical step. That means the vertical step is the same for every level. Okay, here you can change actually. You can change. What we use now is fixed plus horizontal plane. It means that if there's any flat plane, it will machine that plane. Okay, so if you can also choose fixed. Okay, if the flat plane doesn't fall between the vertical step, then it will not machine the flat planes. Of course, the best it will be the fixed plus horizontal plane. Or you can set a variables. In variables, what you need to do is key the max and min. Okay, and the system will calculate the side step for you, and the vertical step. And the vertical step will have different value. Okay, so let's stick to this first. Okay, pre-finals pass known. This value I'm going to explain later on. And here, skip plane close to fixed layer, because we specify we're going to machine a fixed plus horizontal plane, right? Okay. Sometimes the horizontal plane is very close to the layer, maybe 0.1 or 0.01 mm. So to machine that layer with 0.1 or 0.0 mm of stock, it will be very small amount of stock, not efficient. So over here you can still set parameters, okay, to tell the system that okay, I can put in maybe 0.5 mm. So I can tell the system that if the stock remain on the flat plane is more than 0.5 mm, then go and cut. If it is less than 0.5 mm, skip that flat plane. Don't cut the flat plane. Okay. Machine by regions. Yeah. Let me show you some pictures. You can press F1 to get these pictures. Machine by region, it means this. If you have two holes, you will try to machine one hole first and then go to another hole. Machine by layer, it will cut one layer, then jump to the other hole, machine another layer, then come back again another layer, and jump back to another hole for another layer. Okay, so machine by layer is good for thin wall parts, or very thin wall part, so you can avoid the wall from bending. Of course, we normally use by regions to save the cycle time. Z limit, in this case, we're not going to control Z limit. If you need to control, you can also control the top only. You can specify from where you want to cut, or the bottom only to where you want to cut, or you want to specify too from where to where. You can specify. If you choose no, that means the cutter will machine from the top to the bottom. Let's close this. We'll skip some of these parameters. Okay. And okay, let's calculate. Okay, now we have done the first roughing process. Let's close it and check for remaining stock. Remaining stock, change color to this, click show, and you can see we still got a lot of material to be removed by the small cutter. Okay, because big cutter cannot remove the material over here. So we're going to use a diameter 10 cutter for the second roughing process. Of course, if you want to use a flat and mill cutter, it is possible also. So let's go select cutters and let's create new cutters. Maybe we will use now, let's for example flat and mill cutters, rough and mill maybe diameter 10, and change to flat, and this is diameter 10, and cut length maybe 30, clear length maybe 50. Okay, maybe this one I will specify a holder, right? And to change the folder parameters, here the folder parameters. Create new holders. Let's say HD1. Sorry, this is the cutter name, and this holder name HD1. HD, let's say 50. Yeah, this is 50, and this is the height of the holder, maybe 60. How about that? So this is the preview of the holder of the cutter. You can also select a point here to look at the cutter in 3D. If this is okay, just click OK to create a tool. Right? To create the second roughing process is very simple. Okay, it's simple. You just copy and paste. Right? And maybe this one I change to second roughing. Okay. I'll change these cutters here to rough MU10. Change to MU10. And if you want to edit the parameters, you can edit. Just double click the process, and I would set this minimum stop width. Okay. So after the first roughing process, okay, on the workpiece, some area they might have some remaining material, maybe less than 0.1 or less than 10 microns. Okay, if your cutter go and machine that remaining stock that is less than 0.1, it will be not efficient. Okay. So here you can control the minimum stop width. You can say, okay, go and check. Okay, so if I put 0.5, it means that go and check if the remaining stop is more than 0.5. Go and machine. If the remaining stock is less than 0.5, skip that. Okay, this is the meaning of this. Let's go, because this cutter is a smaller cutter. I might need to change the size a bit, and maybe this is flat ml, so maybe I'll change the size to 2.1 times TLDI, 10% of the cutter as the vertical step, 40% will be maintained. That's good. Okay. And how about skip plane the close level? Okay, I'll cancel this. No need. We'll cut all the flat plane machine by regions. And the other setting I will use the same. And next is to set, of course, the RB and the feed rate. So let's calculate again. The cutting speed is 200. Maybe the feed per 2 for this cutter maybe is 0.1. Right, and save. So the RPM it will be around 6,000. Right, the feed rate is around 1,200. Okay, and other setting no need to change. Then just calculate for the second roughing process. Here you are. The second roughing process. You can see the cutter only cut only the material. Let's go and simulate. You can see better. To simulate, you can straight away select the second process. You no need to select all the process. You can start from the second, and the system will optimize the stock. So that means you no need to start simulate from the first. You can straight from the second. Right, now this is the second roughing process. You can see the cutter only machines those material remain that is more than 0.5 mm. There's no air cut. Right. So this is the second roughing program. So now, after the roughing process, the first and the second, let's look at the remaining stock. So as you can see, right, at those horizontal area from 0 to roughly 40-degree area, you have a lot of big steps, and this big step has to remove before you apply the finishing process. So we're going to generate a semi-finishing process. So I'm going to create another cutter, and this time the cutter will be a bonus cutters, diameter 10 mm. Okay, and then select the procedures, and we're going to choose the Semifinish procedures, and we're going to choose this option here, finish mill by linear angle. Okay, and the part surface already selected from the previous selections, and next that we need to select is the boundary. For surface milling, you have to select the boundary. Yeah, and the boundary you can select, let the cutter to touch on, in, out, or as touch point. So I'm going to use it as touch point, and I will select this boundary here. It's not good. To here, to here, and here, here. Okay. So this boundary specifies that this is the area that I want to machine. After finish, press middle button of the mouse to accept, and then press again to exit the boundary option. So after you select the boundary, next, of course, make sure the cutters you select bonus 10, right? And how about motion parameters? The motion parameters, most of it is same. We will maintain the same surface offset also. And okay, here the main difference is at the two trajectory. Okay, so because now we just want to machine all the horizontal area, right? Not the vertical. So here the vertical area, I will cancel it. I don't want to machine. Okay, I just cancel it. And the angle. Okay, so you can specify the horizontal area that you want to machine. If I put 40 degree, it means that I want to machine from 0 to 40 degree the horizontal area. And with this one, you have the options to whether to machine by spiral cut or parallel cut. Okay, parallel motions or 3D steps. Okay, 3D step you will have a constant pitching. But since this is a semi-finishing spiral cut, I think this is good enough. And cutting, I'll choose climbing and machining. Okay, in semi-finishing, it is good to machine from inside out so that the tool will come in inside the region. Okay, it means away from the wall and machine to the wall. Okay, if you choose outside, the tool might come in from the wall, okay, and machine toward the center. So this is bad. So let's change to inside out and horizontal step. For training purpose, I will use a 0.1 of TLDI. Okay, true spiral is good. Okay, and other parameters, everything is good. And next is to set RPM and feed rate. Okay, so I'm going to use the same RPM and feed rate for this ball cutter also, and click calculate. Okay, now you can see all this is semi 40D, okay, degree regions. Each for horizontal, for example. So you can see all the 0 to 40 degree regions being machined again with the bonus cutter. So let's look at simulations. Okay, so let's look at simulator. So you can see the tool is cutting from inside out. So this will prevent the tool from plunging in near the wall, especially at the bottom. So it will cut all the steps, okay, at the horizontal area between 0 to 40 degree regions.
It's 5 o'clock p.m.
Okay, let's close this. Now after the semi-finishing with the ball tank, let's check for remaining stop can. There you are. So we can see that of course the finishing cutter that we're going to use for this part, it will be a ball tank. Yeah. So if we directly apply a ball tank, and we can see that at this corner here, Okay, during the finishing machining, the cutter will have a high load, and it will vibrate or jerk, and it will not give you a good corners. Okay, because material over here, a lot at the corner. So one way to remove the material at the corners, yeah, is you can use a bonus cutter or a cutter diameter 10 bonus cutter, or maybe slightly smaller, diameter 8. Okay, so I'm going to create another 8 cutters, and this time this will be a rough and maybe diameter 8 cutters. Okay, slightly small cutters, diameter 8. The rest is the same. And now I'm going to create a penciling programs, okay, on this part to clean the corner before the finishing. You can use penciling for other purpose also. To create the penciling, now make sure you highlight the last process and click on this process, and the boundary and the surface is selected from previous process, and just change the cutter to BN8, ball 8, and okay, the penciling is here, is in a remachining and pencil. Okay, this is penciling. Of course, after make sure you selected the ball 8, and let's go to motion parameters. So the main difference at the motion parameter is here at the tool trajectory, yeah, and climb. Of course, we're going to machine it climb and slope limit angles. Okay, so if I put 40 degree, that means 0 to 40 degree is considered to be a horizontal corner. 40 to 90 it will be a vertical corner. So here you can specify what you want to do, right? You can specify both up and down, or all up only, or all down only. Okay. So I'm going to choose up and down and calculate. Of course, maybe I'll change my machining parameter, RPM 200, and this again maybe 0.08. Okay, so the RPM will be 8,000 for this cutter, and the fill rate may be 130, and then let's calculate. Now this is the penciling process. What you do, you will go to, let's navigate, go to navigator and check, right? You will go and cut the corner one time, okay? Of course, this one also with a surface offset of 1 mm, okay? Cut the corner one time to remove the excess material at the corner, so that the finishing cutter will not vibrate and last longer. Okay. Okay. So this is one pass. So sometimes if you might afraid the load at the corner here is too high for one pass, too high. Then what you can do is you can specify a multiple pass by changing this parameter here. I can say I want to machine 2 pass, okay, and you can have the option to have an incremental jack or surface offset. Normally I would suggest use a surface offset. I want to machine 2 pass, and maybe I put 0.5 1 pass. All the default, no, let's say I put 0.05, okay. 0.4, maybe I put 0.1 for training is okay. Okay, 0.81 pass, and calculate. Okay, now you can see here, instead of one pass, you have two pass with 0.mm down step. So this will avoid the penciling tool from broken, okay, due to the high load of the corner. So you can simulate the process. And this is the penciling process with two pass. So it will cut the corner one time to remove the excess material. It will help the finishing tool. It will prolong make the finishing tool life longer and less vibrate at the corner. Okay, so this is a penciling process. Now we will look at the finishing process. So I'm going to create a new cutter, a ball cutter, finishing PN